what happens with the washer is you end up getting a hole in the middle. So when we're doing the washers, I'm going to have you put some dimension on this. So take one of your colored pencils and put a little dimension on this thing. So go like that. Give it a little. It's hard to work in 3 dimensions when our paper is 2-dimensional. So I'm going to have you give this a little dimension. So back shade it inside and front shade it there. What you're going to have when you start making those cross sections, or when I'm going to start dishing you up a slice, is instead of having a solid disc, you are going to have what we call a washer, which is basically just the disc with a hole drilled out of it. Well, if you were to go back into geometry class, you can kind of think, again, I could just hand you the formula and you'd use it, but I want you to understand where it comes from because it really helps in retention. In geometry class, how would you get the volume of this? Large cylinder minus small cylinder, and that's where this formula comes from. Ignore this. If I were going to just find the volume of this one washer, and if I were in geometry class, we would have called this its height, and you would have just said big cylinder, pi r squared h, minus little cylinder. That's exactly what we're still going to do. So don't lose track of this. It's all about the cylinder. This is how the formula gets morphed for us. We factor or front factor the pi, so the pi is going to come out front, but we're going to back factor the h. So pi and h are in both of these. Pi we're going to pull out front, h we're going to pull out on the back side. What that leaves is big radius squared minus little radius squared. And just like we've been doing all year, our h becomes a what? A dx. So when I show you the formula in a little bit, if I were to pull it out of the textbook, it's going to be pi r squared minus r squared dx. But we're going to add them all up. So what are you going to see inserted into the formula? An integral symbol, right? Where is it going to be? Right after the pi. Yeah, so we'll get there. But that's this one washer in calculus notation. So what do these look like? Go ahead again. It's all about a good sketch. So we're just doing lots of coloring today. I don't even want you trying these yet. I just want nice, chilled, easy, good picture. So what I'm going to do now is I'm going to loft a figure. Maybe I'll still do that. Let's go up here at 1. Let's still use the square root function, but perhaps it said the square root of x plus 1. So it was lofted a little bit. And let's make it bound here by y equals 1 maybe. Just doesn't matter. Go ahead and shade that in. I will do the same. They should make a nice shading tool on this smartboard. All right. I suppose not many people use it for this purpose. I have to tell you what I want you to rotate it around. We're going to do a horizontal rotation, so we'll just use the y-axis for the ease of it. But what's going to happen here when it rotates is you can kind of see it. Let's do it dotted. You're going to have this symmetry going like this. So go ahead and kind of shade that in. It's going to have a circular bottom. It'll look kind of like this. And a circular top. There. Hey. That is one of the better ones I've ever drawn. I deserve a round of applause. Thank you. Thank you very much. Thank you. I'll be here all day doing this all day. Just kidding. I like it. All right. Anyway, poor Rachel sits up front and I always walk right here. Anyway, right here, that's the solid that's going to be created. You'll notice I'm going to still take the same approach. Watch how it's going to change though. I always draw my rectangle in the shaded region perpendicular to the axis of rotation. So you're still going to go like this. Then I would suggest you attach it to a piece of invisible string. Let's call it dental floss. And attach it in there so it looks kind of like a nunchuck that you're whipping around there. It's going to create that empty space in the middle. Can you see it? Right? My goal is to figure out the volume of the solid. Well, it's all about the cross section. So we're going to take that red thing that I just whipped around and we're going to take a look at just the one. So kind of swing around. You do that. It's going to have a hole in the middle. You do this. and then you shade on opposite. This could be art class today, couldn't it? Shade on the opposites. There you go. There's one, and then we'll take and stab our y-axis right through the center. I'm on a roll with my sketching this hour. I'm just going to keep drawing. All right, so there is the one, what we call washer, that would get created, but how many are we going to have whipping around there? Infinite amount, so keep that in mind. But if we can just get the volume of one of them, the integration process takes care of all the infinite other ones. So what is the volume of one of these cross sections? Well, it depends on what this is, which we're going to call the radius, and it'll be a function of x when we've got this dx problem. So we are going to do pi times the big radius squared times the height. That'll give me the whole thing. You can anticipate what I'm going to do, can't you? What am I going to do now? Subtract. Yep. We're going to subtract off pi times this inner radius right here, which we'll be able to get a function for, dx. And then all we do is factor. We front factor the pi, we back factor the dx, and in parentheses, we do r squared. And I'm just going to write big R squared minus little r squared. That's one of them. One of them can turn into an infinite amount the minute I put up an integration symbol. So I'm going to integrate from left to right along the x-axis. Pi, big R squared minus little r squared dx. Do you get to use a formula sheet for the AP exam? No. Do you think you get to use one on your Chapter 7 test? No. So there's got to be a way for you to remember them, and this one's all about the cylinder. Area is all about the rectangle, base times height. This is all about the cylinder. So let's go and shake it up a little bit. One more sketch. We'll see how far we get here. So what I'm going to do on this one, I'm going to take this exact same figure. So let's go do that. Let's loft it one up. Go like that. And then again, just watch and listen carefully today. And we won't practice until tomorrow. Go shade that in. Now I'm going to change this. I want you to do a vertical rotation. So for ease, let's just go around the x-axis. Again, this changes the volume, it changes the solid, it changes it significantly. How do I draw my representative rectangle? How am I going to draw my rectangle? Help me out. Perpendicular to the axis of rotation. So it goes in my shaded region, perpendicular to my rotation axis, and then I'd put that little invisible piece of dental floss in there just for a good picture. And then notice now I've got dy's. So if you can picture the solid that this one's going to create, it's going to head over here, and it's going to go like that. And it's going to be another like vase, but it's going to have a divot, like a V divot in it. You don't have to draw this full picture, but you can kind of see what it's going to create if I shaded that over there. It's going to be like a vase that has a central, oh, that wasn't the best picture, was it? Make yours look better than mine. Yours is good. Yours are going to be great. I already know that. He likes to color. Dylan loves to color. I won't have to say this. This section, I won't have to say, put your colors away, Dylan. Because you should be coloring. All right. So for this one, we're still going to have the same type of deal, but we're going to be going up, and our things are going to look like this. Oh, I forgot I have my headset on. Sorry, Dylan. Everybody can hear me mock you on video. All right. And hear me go. All right, anyway. There is my new and improved with the x-axis stabbing it through, y-axis, and it's spinning this way. But again, here's the only thing that's going to change. I am still going to have a radius. It's just going to be given in terms of what now? Y. Exactly. The x is going to be, it's going to be some function of y. And my inside radius is the same thing. It's just going to be solved for x in terms of y. And again, my formula is going to be identical. Here's the only difference. It's going to be some function of y squared, and it's going to have a dy on the back of it. Otherwise, it's identical. So the picture really helps you decide what your radii are, because they're the key components in here. You're going to find that tomorrow when you're working. You're going to be, oh, I had the wrong radius. Everything else will be fine. A few of you will forget the pi. I always do, actually. That's my big thing. So now when I do my integral, I'm going to be going up the y-axis, so I'd probably have different limits, not always. And my big R and my little r are y-dependent. What do you think? Can we do one? We're going to go try. You don't know yet because we haven't tried. We'll go try. I didn't do this page, and I don't want to. I want you to go right here. All right? What time are we done today? Oh, I'll definitely get as far as I need to. So, and I'll just quit there. We'll maybe just chat the last 5 minutes. So here's a problem we're going to do in full. And it's already graphed for you, but beware that when they graph it for you, you really need to be 100% who's who, because top and bottom functions matter. So who's the top function, the cosine or the sine? How do you know it's cosine? Yeah, exactly. Cosine 0 is 1. So I would label that. This is your cosine function. This is your sine function. This is where they're crossing. I better know that as well because it's a limit of integration. So we'll figure that out in a minute. So we're going to rotate that about the x-axis. That's important. In the minute they tell you what to rotate it around, I always like to make it stand out to me. Okay, so I'm going to rotate around the x-axis. I draw a rectangle. How do I draw it? You can kind of get the algorithm in because I say it so many times. Perpendicular to the axis of rotation. So you go in your shaded, you draw a rectangle, perpendicular, and then you put that little invisible string on it. And then this is helpful too. Is this going to be a dx problem or a dy problem? Dx, and you might even want to write that down. Is it going to make washers or discs? Washers. Why washers? It's not touching its axis of rotation, so there's going to be an empty, you can kind of see it in here. There's this empty space. It's hard, it's not shaded real well over there. But this is going to make a washer because it does not butt up against the axis. There will be some empty space there with that little dental floss string. So now I'm just ready to set it up. The thing is my washer requires big radius, and I would even write them down right here. Get used to that, and then don't do any calculus until you got it all set. Your radius is the axis to the outer edge of the curve, which will be top minus bottom, which is obvious. What's my big radius? Cosine x. Yeah, it's just cosine x. My little radius is axis to inner edge, top minus bottom. It's just what? Sine x, which is obvious on this one, but again, that top minus bottom is really helpful when we start messing with the axes. So now I'm ready. I'm ready to set it up. I need to integrate, right? From where to where? Where's that? No. No. Why? Yeah, you're right. Why pi over 4? Yeah, that's where sine and cosine are equal. So that's actually pi fourths, and this is root 2 over 2 comma root 2 over 2. But yeah, it is pi fourths if I'm going to be in radians like that. So excellent. So I have to integrate from 0 to pi over 4, big R squared, minus little r squared, with respect to x, and I purposely made the most common mistake you will make. Once you get good at them, that's the mistake you're going to make. I forgot the pi. Yeah, exactly. So lead them all with a pi. This one, I would just go math 9 on my calculator. This would be calculator active. You could just math 9 it. And again, your answer will represent the volume of this solid created by revolving that around the x-axis. So we are just going to wrap this up. Here's what you're going to be doing. And first thing you need to do, you are going to need to, again, let's see if you remember, you draw a picture, a really good picture, a big picture. You shade. Then you draw your rectangle perpendicular to your axis of rotation, wherever that might be. You might want to highlight that or put that in a box. Before writing an equation for big R and little r, get them on your picture. By the way, write this over here, big R. When you're thinking about what it is, it's the distance from the axis to the outer edge. So you will, and it depends on which one's on top and which one's on bottom. Sometimes you do this minus this, sometimes this minus this. It's top minus bottom though. Depends on where we put that. You'll see tomorrow. Little r is axis to inner edge. And again, to figure out what that length is, whichever one's on top comes first. Top minus bottom. Once you're done, all right, don't forget about the pi. And be careful you don't do that. College Board says that's one of the top 10 biggest mistakes. What did that person do? They put that in the top 10. They squared the quantity, which means that the formulas, be careful, it's not that. It's each one individually. So other than that, we are done. I want to see what the next page is here. Yep. Oh, sorry. I have to get through part A. That's how far I got in first hour. Do I have time to get through part A? All right, because my notes pick up from right here. So your assignment's going to be to watch the notes. Where are you going to find them? Schoology, and when you come in, that's actually a homework assignment. They're like 15 minutes, 20 minutes. I don't know, I did them during my prep. Let's go quickly, see if I can get through part A. We draw y equals x, which is this line. And it would go this way too. I just know from first hour I don't need that part. Y equals x squared is this parabola. That right there, that little banana shaped thing, is my region. So we're going to go shade it in. There. I'm going to rotate it for part A around the x-axis. I always like to make that nice and bold. So let's see if you remember. What's the very first thing I do? What do I make? Rectangle. Oh, I heard, yeah. Let's make the rectangle perpendicular to the axis of rotation. Decide that it's dx, so I know everything's x's, which is your favorite. You hope that happens, and it happens most of the time. And is this a disk or a washer problem? This is totally washer. It's going to make a really kind of pretty vase with a curved edge and a nice V insertion in here. So it's pretty. It's a dx. It's a washer. All I need to do is figure out what my big radius is and what my little radius is. Big radius, axis to outer edge, top minus bottom. What's the top? X. What's the bottom? 0 for that one. But keep in mind, had I rotated around the line y equals -4, then I go minus -4 to make sure I add that. You know what I mean? So it does matter. It's just that it's 0 here. So x minus 0. My little one is axis to inner edge. What's that? X squared. Technically minus 0. You don't need to put the minus 0 on there. Now I'm ready to set it up. What am I going to do? I'm going to integrate. I'm going to remember my pi. I'm going to go left to right. So where to where? 0 to 1. Awesome. You guys are so good. All right. What comes first in my integrand? I'm not memorizing formulas. I'm doing pi r squared h minus pi r squared h. So I need to do r squared minus little r squared, and there's your h off the back end of it. From here, it depends on the directions. By calculator, math 9. If it says leave it exact, but use your calculator, then you enter that under math 9 and tack a pi onto your answer. If it says entirely exact, no calculator, then what do? Antiderivate. Right? Or antiderive. I don't know. I'm done. What's your homework? That's it. Notes and Schoology. I want to hit done, but I don't know.